and start load calculation, residential. Okay. Residential load calculation. Example. Okay, example number one, guys. I have a multi-dwelling apartment. Multi-dwelling apartment. It has let's say, make it, spice it up a little bit. Let's make it 30 units. Let's just put the requirement here first. It's number one, the units. Units equal 30. 30 units, 30 apartments. Okay, it has 30 apartments in it. Each apartment unit square foot equal 1,000 square foot. They must be in New York or somewhere else. That's small apartments, right? 1,000 square foot for each apartment. 30 units. So these are the coming. The other thing is the voltage system. Voltage we're dealing with here is 240/120 volt. So because Chris said this level, I can use 208/120. We decided to use 240/120. I could have used 208/120, by the way, for this apartment. That'll be a good exercise. Okay, inside each apartment, we're going to find the following. Let's look at first the air conditioning. We have air conditioning for each apartment. Each apartment has an air conditioning of let's say 30 amps at 240. The load is given on it, 30 amps at 240, and each apartment have a heating system. My heating system, guys, is given as, for each apartment, as 10 kW. 10 kW. 10 kW. Okay? 10 kW heating, space heaters or whatever. So that's given. The third one that we have in this apartment, we have a range, each one of them, range. And the range that we have for this apartment is 16.5 kW. We also have a dryer to make things more interesting. We have a dryer, and in the dryer, I have, let's just say 6.5 kVA for the dryer. kVA for the dryer. Air conditioning, space heater, dryer. And the last thing I have is I have a waste disposal or garbage. Let's just say garbage disposal. Garbage disposal. This baby is running 1.5 kVA. And I have right here, I have dish washer running at 1.2 kVA, and I have water heater running at 5 kVA water heater. That's it. Now I'm going to spice it up a little bit and tell you they have a swimming pool with a pump, and that pump equals 7.5 horsepower. 7.5 horsepower. Just to spice it up a little bit. They have a swimming pool that they want to pump, and they have 7.5 horsepower. And the voltage, oh, by the way, the voltage for this is 240. Okay? So let me just highlight a few things here. Everything that you see is per unit. Everything you see is per unit except the pump. The pump right here is only one pump. Only this number is only one pump. Okay? Just one pump. Just to get you not confused. So, what's the question would? How size the service to this building? Isn't that, typical? Size the service to this building. Size the service to this building. Any question guys about the given? Now you can plug this one in Excel and do the calculation in a heartbeat. The most important thing actually is to ask yourself, what is my voltage system, Chad? Am I running this apartment 240/120 single phase or 281/23 phase? Because that changed the whole calculation. We're running in 240/120 single phase. Any question guys about this? Shall we go ahead and do the calculation step by step? I know you told me I go fast, so I'm going to slow until you guys tell me to move. Oladipo? No, they didn't tell me that I'm going fast. I'm just asking. Nick, you told me, am I going too fast now? Slow a little bit. Press, thank you, Press. I need somebody to say, stop, Chad. Are you guys happy this week, or what's going on here? Okay. Cool. Any question, guys, about the multi-dwelling unit? Multi-dwelling unit? Multi-dwelling family dwelling, multi-dwelling unit?
So the units have dryers, but they don't have washers. Drying them.
Do we have, oh, that's a good idea. Do we have a dishwasher, dryers? You know that the washing machine, the washing machines, the reason why they don't put the washing machine sometimes, anybody remember what do we do for the laundry circuit? When we give a laundry circuit, we give a laundry circuit a 1.5 kVA, right? That's why laundry circuit sometimes not mentioned. That's why even in my codes book, if you look, I don't think he mentioned a washing machine.
Oh, so it's just plugged into the same
Because it's plugged into the receptacle for the laundry machine. Remember that receptacle at
You don't need
1.5?
one for each, just one for the washer and dryer. So the 20 amp.
No, we have a dryer. Don't we have a dryer? We have a dryer. But the washing machine itself will be plugged into the 20 amp circuit for the laundry.
Okay.
And the dryer will have its own big
If you have a
30.
gas dryer, is it acceptable
Yes.
to put both appliances on the same 20 amp circuit?
If you have a gas, yes. Yes, absolutely. 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 It's not electric dryer. Yeah, absolutely. Okay, so I'm going to start with general load. Can I move? No? Yes? Cool. Okay, so let me see what I'm going to be using. Blue is a good color to use. So I'm going to remind you guys how many units and the square foot of each unit. The first, by the way, I'm following steps from the sheet that I gave you. So when they say step number one, guys, or number one, that's directly from the sheet that I gave you. So I'm going to say number one, general light. General light and receptacle. General light and receptacle. The table for this baby is going to go from 220.12. And here's the calculation that we're going to be using, right? 220.12. It will tell you, you need, so we're going to take a 3. If you guys go to table 220.12, table 220.12, and you see, it will tell you 3 volt amp for every square foot for the apartment. So 3 volt amp multiplied by, how many square feet do we have? 1,000 multiplied by how many units do we have? 30. I need somebody with a good calculation who is going to get an A with Mr. Curly to tell me the steps here. Okay, 339, that will be 9 in K. Can we get it in K? 9, 1, 2, 3, 4, 90 kVA. Am I right here?
Yes.
90 kVA. 1, 2, 3, 90 kVA. Okay, cool. That's step number one. 90 kVA. Now step number 2, we need small appliances circuits. Branch circuits. That's number 2 right here in front of you guys in the sheet. It says, I'm going to go to 250. For this one, you need 220.52A, the most important one. That's where you get this info from. And it says 2 small appliances. Each one of them is going to have 150. Okay, so two small appliances circuit, 1.5 kVA each. So let's see what we're going to be doing here. We're going to take a 2 for every apartment, multiplied by 1.5, multiplied by how many apartments do we have? We have 30. Any question, guys? We multiply two small appliances circuits minimum. Why 1.5? Because the code 220.52a tells you 1.5 K, 1500 volt amp. Multiply them by 25 because I have a 25 apartment. I need a calculator, Chris. Can I depend on you today?
Yeah.
What's the answer for that, baby? 339. Would that be 90, right? 90 K VA. 90 K VA. Is that true? Right? 339, and this is a K. Don't forget that there is a K here. I should write this one better. 1.5 K. So 339 90 kVA. Wow, it's as big as the whole three. I guess it's the same thing.
Yeah.
1.4. Yeah, the same. So look at interesting. The kitchens will take the same amount of power as all the light and receptacles. Is that interesting? Unless we did something. I don't think we did anything wrong. Okay, so that's small appliances circuit. Number 4. I'm skipping number 2 because number 2 was branch circuit. So write yourself. I'm following the sheet that I gave you guys. I care less about number 3. So this will be. I'm sorry. This should be actually in your based on the sheet that we have. Based on the sheet that we have, this should be number 3. What happened to number 2? Number 2 was branch circuit calculation. How many 120, 15 amp, and 20 amp circuits you need? I care less about this step. So just to continue with the stuff that we have, I need number 4 here. Number 4. Any question, guys, where the 2 happen to be branch circuits? I'm following the sheet that I gave you. So just stay on the on that one. Laundry branch. Laundry branch circuit, right? Laundry branch circuit, if you guys go to 250, not 250, chat, 220 dot something. And this is branch circuit. Uh, 220.52b. If you guys go to 220.52b, you're going to find the following. It will tell you 1.5 for every laundry circuit. How many laundry circuits do I have? So if you go to this one, it will tell you the following. 1 circuit multiplied by 1.5 K multiplied by how many units do we have? 30 units. And that will get me 3, what's Chris? I lost my mind here.
Oh, that's 45,000.
45 kVA. 45 kVA. Right? 30 units, 45 kVA. Any question, guys, about these? Any question about this? Straightforward? Where you found it? Okay, I'm going to slow down here until we go to step number 5. Any question about this? Do math. Now, Tom, my friend, go ahead and do your calculation, guys, and design your Excel sheet to do all this math for you. It's just simple math. One more time. Everybody knows that I'm following the step by step that I gave you guys here when I say these numbers. So I skipped number 2 because it's branch circuit calculation. I care less about it. It's not even in my sheet here. Okay.
Why is it there?
Why is it there?
Yeah.
Because I used to care about the branch circuit at one time, and I honestly I have to go change it.
Related to that 214?
Yeah, there's something in the code, following the code calculation.
14?
Yeah.
Is that what the space it occupies?
Yeah, how many 120, 115 and 20 amp circuits you need. I think it came, all these came from the example in the code book where it tells you how many branch circuits. Branch circuits as designers, we design them different. We design them slightly differently. So I care here about the size of the surface. Okay. Can I have everybody say yes, Chad, move? Yep, yep. You guys told me I move fast, so I'm gonna be as slow as it gets. Nick, my friend, we're cool.
Okay.
Dustin, my friend, we're good. Ashley, we're cool. Okay. So let's go to step number 5. Step number 5, based on what we're saying, guys. Step number 5, it says add 1, 3, and 4. We're gonna add them up. Add the steps 1, 3, and 4. So I need somebody to add them up for me. Before we do that, we're gonna go. So general light. I need somebody to give them to me. Okay, Chris, you can give it to me, please. So I have general.
We got 90,000.
General was 90K. 2 small appliances was also 90K, and laundry also was how much? 45?
45.
Okay, so we're gonna add them all up. 18, Chris?
225,000.
225 kVA. 225 kVA. kVA. This is just adding up. Number 6. And this would be my 90K, 90, 45, 225K. I just put them in. And I want to highlight this one. Then, step number 6, demand. That's easy. Demand load. Oops, let me continue with the same. Demand load. Demand load for everything, guys, here, it tells you 220.42. If you go to table 220.42, it will tell you have to apply a demand factor for this. A demand factor for this. 225. Okay. 225. Should have done that. 45. 90, 45. Just to stay with the convention that I'm using here. K, and K. Okay, 225 kVA. 225 kVA. kVA. If you guys go to 220.42, it will tell you have to apply demand factor. Let's go apply the demand factor. If you guys look at this table, 220.45, let's start with the following. Here's what the table tells you. The first the 3K, leave him alone. The first 3K, I'll start right here. The first 3K, leave him alone. The first 3K, leave him alone. Up to from 3,001 to 127, cut them by 35. Then this is very important, guys. How am I going to do that one? The first 3K. So the first 3K, leave him alone. Then up to 117K, cut them by 0.35. Anything higher than 120, remainder over 120, cut them by 25. So take the 225K minus 120 and multiply these babies by 0.25 and get the answer. Okay, very, very important to know how to apply this rule. Very important, guys. If you guys look at the table, please be in page 65, page 64. Page 64. It will tell you the stuff that we calculated here. You can demand it. Means you can cut it down. The reason why we demand, because anybody knows why we demand them? Highly unlikely that you and all your neighbors are cooking The air conditioning is fully on. The range is fully on. All the lights are on. All the receptacles are on. What else? The pump is on. No, all the receptacles. No, these are just receptacles. All the lights are on, and you're cooking at the same time. Or the kitchen equipment are on at the same time. So it's highly unlikely. Diversity factor, demand factor, diversity factor. I'm sorry.
Where did we get the 117 from?
Interesting. Very interesting. The first, let's just look at the 3K. Any question about the 3K, guys? 3K straightforward.
Minus 3K from our 25.
That's it. That's it. Any question about the 3K? If you look at the table, it tells you the first 3K, leave him alone. Please don't touch him.
But
Okay?
225 minus 3 is 222.
Then,
Right?
hold your horses. The first 3K, leave him alone. More than 3K up to 120. What's higher than 3K up to 120? 117. This number here, guys, this is the most confusing one. This number came from here. Came from 120 minus 3. 120 minus 3 give you what? All the time. 120 minus 3 give you what? 117. Why? Because the first 3 are already gone. Right? It's accounted for. And the code says up to 120, between 3 and 120, you have to apply 0.35. So what's the number that you take away 3 from it, and you can't go higher than 120? 117. This is, again, the most confusing part is what is the 117? 117 is basically, if you look at the code says from 3001 to 120, 35. So if you take 3K and you put them, don't touch them, out of the 120, what's the leftover? Always 117. Always 117. So here's my 117. Then they tell you higher than 120, please cut them by 25. So higher than 120, here's my 120. Higher than 120, I get it 0.25. Very, very interesting. So actually, my friend, if this number, look at this, guys. If this number is more than 120, if this number here, 225 kVA, if it's more than 120 kVA, then these two here, how am I going to do that? These two are always the same. These two never changes. So take this example. Suppose that this number here, 225, was 500 kVA. Just suppose 500 kVA. This, anything in the black stays the same. The first 3K, leave him alone. The first 17K, multiplied it by 35. Then 500 minus 120, cut them by 0.25. Are you with me? Because that's the most confusing one, is the 117. 117, if your number is high enough to exceed the 120, this number, if it's high enough to exceed the 120, these two steps stays constant all the time. Then you take this number. So if it was 120, look what happened if it's 120. If this was 120, 120 minus 120 give you what? 0 times 0.35. Then it becomes 117 times 0.35. Any question? That's again the most confusing part, is how to apply that rule at that level. Because the apartment that we have, Nick, was low enough that this number, if you remember, guys, was not even close to 120. That's why we don't have to apply the 120 step. Any question? Let me repeat myself one more time. If the calculated load here is more than 120 or more, then these two steps, 3K and 17K multiplied by 0.35, stays constant all the time. You don't change them. The only thing happens is you do the math right at the bottom. If this number, look at this. If this number, guys, is less than, if this number is less than 120, then you do the same thing. Here, you put that number minus 3. Like we used to do. Remember that? The calculated load minus 1.3. Take this. If this was 90, Phil, take this one. Let's assume this was 90. What do you do? The first 3K, now 90 is less than 120. So these rule, so 90. 3K, leave him alone. Take the 90 minus 3. 90 minus 3, that will get you 87 multiplied by 35. What happened to the last step at the bottom? Doesn't exist. The last step happens, it plays role if this number is more or equal to 120. It makes sense. Any questions about this? Did we kill this sheep? Okay, I need somebody to give me the, now we add them up, so please don't forget to add them up now. So 3K, 3K, anybody came up with an answer? So I have 117 times 0.35 plus 3 equal plus 225. I should have done the 225 minus 120 equal times 0.25 equal plus 3 plus open brackets 117 times 0.35 close the brackets equal. I have 70.2. 70.2. Anybody came up with something different? 70.2. Okay, 70.2. 70.2 kVA.
That's your total.
That's my total.
You got 3,000. That's the second number.
The second number 117 times 0.35.
Okay.
117 times 0.35 equal plus 3 equal plus open bracket
40,950. Right?
minus 120 close times 0.25 equal 70. 70.2. Anybody came up? I came again with 70.2. Unless I'm
Yeah.
70.2.
Yep.
I have a second and a third, a fourth. 70 point. You no?
No.
Okay. Oh.
Right, no, check.
Let's do it. No problem. No problem here. Thank you. So let's just do this one right here. Translate this one to 3K. Then this will go to 0.35 times 117 equal. This will give you 41K, give or take. And this one will give you 225 minus 120 equal times 0.25 equal. This will give you a 26.3K, give or take.
My confusion is the very first step of the 3,000 K. So
This one?
We're minusing that?
No, we're adding. Everything is added. Everything here is added. This to this to this.
Like 3 kVA times 1 equals 3.
So we, yeah, here we took this 3, then we took here, then we adding these, and that should give us 70, right? So it should give us 70.3K or 70.2K. Yes, sir.
So the 3 that we take off at the very beginning, we add that.
We add it to the total. Yep. The 3 that you take and put aside, it says at 100%, guys. That we put it aside, guys, just not to derate it. That's the reason why we put it aside. We did not throw it. We just put it aside so we don't apply the derating factor on it. And that doesn't make sense? No? Okay.
Well, I mean, I wanna get it right.
Okay, go ahead. Keep doing it.
I'm still, Chad, I need 3 plus this plus this.
Okay.
Plus this. My calculator.
No problem.
Those parentheses down there are screwing me up.
Okay. I think
Sorry.
no problem. No problem. Let me do it. Let's do it in the second step. Okay. Let's see. I have 3. And the second one was let me see here. Oops. Where's that one here? Okay. Get out of my face here. Okay. So the 3, the 17 plus 0.35. Okay, come on, buddy. There you go. 17.35. Then 17 times 0.35. I'm going to do this math for this. And the second one is 225 minus 120, okay, and multiplied by 0.25. Okay, so this 17, this straight 3 stays as 3K. Question about that one next? Still 3, the first one? Okay, the second one, what did we say that one? 117 times 0.35 equal. This is 41. The answer for this one is 41 kVA. Any question about that? The second one? Just straight math. The third one, let's do the math in steps. 225 minus 120 equal. This one equal 105 times 0.25. And if you do that, times 0.25 equal, that will get you a 26.1.
Thanks, Jeff. That's what I needed.
Okay? And then you add them up, right? Then let's do it continue. That's okay. Then we go 3K plus 41K plus 26 point what's that point? 3.3. Thank you. 26.3K. That should give you, what did they say? 70? 70.3 or 2. kVA. Any question, guys, about that? I just didn't do all this math, but thank you. That's how it should. Make sense now? Okay. I'm sorry. I tried to skip lump sum them all in one, but that makes sense. You take it one step at a time. This will be right here. The second, the third. Oops. Okay. All right. Okay. All right. So, any question, guys, about 70.2 or 0.3? We're going to use the 0.2. 70.2. Any question about this? 70.2. Now, do me a favor. Guys, can you do me a favor for the 70.2? Can you put stars, highlight that one, because that's what I'm going to be carrying downstream. I'll just put stars next to it because I'm going to be carrying that number downstream. Okay? I highlighted so because when I start carrying things, I don't want to get confused. Which number am I going to be carrying? That number that I put the stars next to it. So, because of this, I'm going to go get rid of these so it doesn't confuse me. Or I can circle it in black in my case. I'm going to also circle that baby in black. So that's my demand. Okay, let's go to the next step. Okay, good point. I like that one, explaining it. No problem. Okay, I'm going to go to the network electrical range. Let's go to step number 7, right? We were at 6, guys. Step number 7. 7, range. For the range, it's piece of cake. You're going to use table 220.55. Okay. And now, what's the size of the range that I gave you guys? 16.5. I have 16.5. If you take this one to this table, let's do the rating now. All of them the same size. 16.5 K. All the same size under this table, 220.55. How many of them do I have? 30. Remember, I have 30 of them. So if you guys go to the table, for 30 of them, under B, for 30 of them, under B, that will confuse you. It says 15K plus 1 kVA for each range. You have to go to 220.55 first. If you guys go for 30 of them, under page 66, I have 30 of them all under B, because they're more than 8 3/4, right? For 30 of them, you guys agree that it's 15. It says 15 plus 1 times 30, and that will get me 45 kW. Anybody does not know how I came up with 45 kW? First, yet we're not done yet. I have 16.k under table 225, under item B, if you guys go to column B, it will tell you 15K plus 1 kVA for 1K for every range that you have, right? Column C. Why did you write column Oladipo? Why did you write column B? Column C. If you go to column C, it will tell you that you have 15 plus 1 kW for every range. I have 30 of them. 1 times 30 equals 30 plus 15 equals 45. Chris, does it make sense? We're not done yet. We're not done yet. That's step 1, to the rate for ranges. All of them the same size, remember. They're all the same size. So we apply note number 1. Okay, then it will tell you if it's more than 12, guys, increase anything. If it's more than 12, for every 1 kW larger than 12, increase it by 5%. What I'm saying right now is note number 1 under the table. Note number 1 under table 220.55. If you guys read it, it will tell you anything larger than 12 kW range, increase it by 5%. So here's what we're going to do. We're going to take that's step 1. Step 2, we take the 16.5K minus 12K. That will get me 13. Right? 3.5 or 4. What am I doing? 4.5, Chad. I need to eat. 4.5 kW. Now, if it's more than 0.5, it goes up. So this becomes 5 kW because the 0.5 goes up. Okay, so I have 5 kW more than 12. Now for every kW more than 12, I have to increase the demand by 5%. So how many kWs do I have more than 12? 5. I need to increase 5 for every one of them. So 5 times 5 plus the 45. So that's where I hope you guys with me. So I need the total is, you're going to take the 45 well, let's see the demand first. So I have 5 times 5 equal 25%. This is from note number 1. Note number 1 will tell you for every 1 kW higher than 12, increase the demand 5%. I have 5 kW higher than 12. I increase 5% for every 1 kW. So my increase is going to be 25%. 25% of what? I'm going to increase this number by 25%. How do you increase a number by 25%? 2 ways. Either you multiply it by 1.25, or you take the number, add to it 25%. I like to multiply the number. If you increase the number by 3, how do you do 3%? You take 1.03 multiplied by the number. You up it by 3%. And that's the last step here. So 1.25 times 45. K. Why 1? Because the 1 account for the 45. Why the 0.25? Because that's account for the increase. So that will be my total. 1.25 times 45K equal 56.3. 56.3 kVA. The kVA and the kW are the same in this case. Any question? Can I repeat this one more time? If you guys take the 16 kW under C for 30 of them, you have to calculate the demand for 30 of them. That will get you 15 from the get-go plus 1 kW for every range. That will give you 1 times 30 plus 15, 45. It's not enough. Had these been, guys, 12, we're done. Had this number been 12 here, we're done. But unfortunately, it's not 12. How many warnings? 2,200 warnings. So had this been 12, we're done with these steps. But because it's higher than 12, the code says, note number 1 says, take anything higher than 12, which is in my case 4.5. If it's 0.5 or higher, substantial, approximate it, go up to 5, because this is 0.5, goes up to 1, it becomes 5. Then, for every 1 kW larger than 12 multiplied by 5, 5 times 5, 25. So I need to up this number by 25. How do you do that? you multiply the number by 1.25. This will be your demand for this step, and I'm going to go circle that baby so I know I'm going to be carrying it all the way downstream.
As far as rounding, 0.5 enough?
Yep.
That's the standard rule?
Yes.
The code rule?
Yep, absolutely. Yep, especially the ranges, 0.5 or higher, up, less than 0.5 down. So I could have dropped this down here, the 0.3. Any questions about this? So that's the range. Let's go for the dryers. We're done. This is the step that we're going to carry all the way downstream. Now, Chris, what was the size of the dryers? Was it 6 dryers?
6.5.
Okay, so I did the range. I will hold until you guys tell me move. Then we can go to the dryers, which is step number 8. We'll do the dryers. Any question, guys? Any question? Oladipo, my friend, you guys did load calculation, right? With Gary, so I assume you kind of know the notes. I don't want to go deeper into load calculation, but I can if you want me to.
As far as load calculations.
That's as far as we're going to get to the test.
Okay. Well, Gary, for me,
Okay, we can throw one. Not today. Let me focus on that. I can throw a lecture about load calculation for ranges one day. I can do that, step by step, and how to do all these A, B, and C. I can do that. Not biggie. I usually take the ranges as part of a bigger system here. I don't kind of focus, but not a biggie. Not a biggie. Not a biggie. Okay, 56.3 kVA. Any towel, my friend? Can I move to the dryers? Yes, no, everybody? William, my friend? Good? Good weekend, William? No bar fights, nothing?
no.
Okay, all right. Nobody has any exciting news, guys, to share? Number 8. Oh boy, dryers. And of course, like my friend Chris said, when I say dryers, I mean electric dryers and electric range, right? It goes without discussion. Otherwise, if they were non-electric, they won't even count here. So for dryers, my friend, you're going to go to table 220.54 and article 220.54 table and article. Okay, so let's go. Nick, what was the size I gave you? Did I give you guys 6.5 for each dryer?
6.5.
6.5. So let's go to this table first and see what 220.54, see what they're cooking there. 220.54. Now I have, how many dryers? I have 30 of them. Okay, it says 24 to 42. You need to do this. Now talk about jumble. Look how they say. Okay, let's take 30. I have 6.5K at, this is the first thing I'm going to say, let me put it this way, the rating factor. Okay, here's how I'm going to do that one. The rating factor, for the derating factor, I have 6.5 kVA. Take this one, how many of them I have? 30. I have 6.5 kVA. 30, take this one to table 220.54. Okay, now if you go there, it's confusing a little bit. Here's what it tells you. Between 24 and 42, that's where we are, right? 30. It says 35 minus 0.5 for each dryer exceeding 23. Now talk about fuzzy math. So
23.1.
okay, that's a point. So let's take 35, here's 35%. Minus 0.5, minus, right? Minus 0.5 for each dryer exceeding 23. This is what they're saying. Anything, how many dryers do I have? 30 minus 23 and close. That's exactly what they're telling you to do the math. Fuzzy math, Chris, I know you're looking at. So 35 from the get-go, start with the 35 from the get-go. So this is 35, this is from my get-go, minus 0.5 of anything higher than 23. Anything of what higher than 23? The number of dryers. So take the number of dryers, subtract 23. These are the dryers that are higher than 23. And multiply them by 0.5. And do the math. Talk about fuzzy math. I'm sorry, I wish it was easy. It's confusing a little bit, but 35 from the get-go, subtract from it 0.5 for everything higher. This number, guys, is the number of the range. So take this, Dustin, take this. That if the number of the range was 50 ranges, well, let's just stay in the same, it's a column. No, I suppose that the number of the ranges were 40, so we can stay in the same row, 40. So you take 35 minus 0.5 times 40 minus 23. The only thing that changed in this equation is that blue thing. That's the number of the ranges. That's the only thing. See that blue thing here? That circle blue? That's the number of dryers. That came from right here. The only thing that changes for any calculation under this row. So how do you do the math like this? Now, first I'm going to do it step by step, my friend, this time. So I'm going to take 35% minus 0.5 times 23. 30 minus 23 is what? 7. 7. See how step by step? Then I'm going to do 35% minus, what's half of a 7? 3.5? 3.5%. And equal, this is all equal. And then 3, this is 3, Chad. 3.5. So 3, that will give you a 2. This will be 31.5%. Am I right? Did I do it wrong? 35 minus 3.5 equals 31.5%. Does that make sense? Does that make sense, guys? Step by step. If you do them in a
Are you sure you're not increasing the percentage? You're decreasing the percentage.
Yes, that's what they want. The more dryers that you have, the idea, Chris, is the more dryers that you have, the likelihood, the more is the likelihood that you will not use them simultaneously.
So that in the percentage,
Less, so you should end up with less than 35, which is, we did less than 35.
okay, if I have 100,
Yeah.
100 VA and I multiply it by 0.35, oh, okay, so it's the inverse.
Yeah, we haven't multiplied yet. We haven't multiplied. We're just finding the derating factor yet. Okay. Any question about calculating the derating factor? Then the next step, look at the next step, guys. So that's step 1. Step 2 is take 65 multiplied. How many dryers do I have in this baby? The 65 is the kVA for all, the one dryer, multiplied by 30, multiplied by 0.315 equal. Okay? The first step is to calculate the demand factor. The second step is to apply the demand factor to the total number of dryers. So I have 30. Why 30? Because 30 units. 6.5. Why 6.5? Because each one of these dryers is 6.5. The code say, everybody knows what the code say about dryers for residential? The nameplate or 5K, whichever is larger. So in this case, we stick with 65 because it's more than 5, right? Right, for dryers, guys? 5K or the nameplate, whichever is larger. Okay, so I need somebody to give me the math here. Chris? 6.5 times 30 times 0.315.
Oh, 61.425.
61.425. 61.4. Anybody disagree with my friend? Anybody disagree? And this is the number that you're going to be carrying downstream. 61.4K, right? I need a second or a third. Any second? Okay, let me second him. 6.5 times 30 times 0.315 equal 61.4. I second him, you third him.
Chad, for your 0.5, up there?
I'm sorry,
It should be 5%, right? So you're
0.5. Yep. Yeah, 5%.
5%.
Did I say point?
That's that's in notation for 50%, right? If we were to pound that on the calculator, which we do, it would be 0.05, right?
Um,
0.00.
Yeah, but hold your horses. Everything here is percentage, guys. That's what the confusion is. I should probably get rid of the percentage sign here. Everything here is percentage. I know where your confusion is. Everything here, 35%, 35%, 35%. Everything here is percentage. You change it at the end to everything here is percentage. So I'm going to get rid of this one too. Okay?
I think the question is where do you get the 0.5 from?
0.5 from the code.
Right here.
Right here.
Right in the table.
Yeah, 0.5. Right? Do you guys see where the 0.5 is located? 0.5. But we're calculating percentages. I know where the confusion is. 35%, 0.5%. So just get rid of all the percentage. Do 35 minus 0.5 plus blah, blah, blah. Do all this. And the answer at the end should be in percentage. But if you want to convert 0.5 into decimal,
No.
not at this moment. You can.
0.5 of 7.
Yeah, good.
Oh,
0.5 of 7. You understand?
Yeah. We're trying to find the percentage, guys. We're trying to find the percentage. That's what we're doing. At the end, we converted the percentage into decimal. Way at the end. Right here. So this really should 31.5, your answer. But what are we calculating? Apples, oranges, dollars, or percentages? We're doing percentages. You get very confused if you convert this 0.5 into decimal. And if you cache the percentage right here, wrong. Don't cache the percentage. 35 minus 0.5 times these two. Everybody knows, guys, when we have math, the order of operation. Everybody knows the term order of operation, right? When you always do the brackets, and then division, then multiplication, then subtraction and addition. But anything between the brackets, you always do it first. Order of operation. Any question? Phil and Rob, does it make sense? No? Confusing? Confusing a little bit?
yeah,
Okay.
my decimal.
You know what? Can I take another example of just to do the percentages? Just for the percentages. Because up to here, any question from this one down to here? Converting 31.5 percentage to 0.315? 2%, cash the percentage. I'll take one more example about just the calculation, guys, for that. Then I need to give you a break, though. Should we do after the break? Okay. Why don't you guys take a 5 minutes break? We'll do a calculation regarding this. Continue here. Okay. So this is the number that we carry. So let me just take one more example. It has nothing to do with it. Suppose this is extra dryer example. Take this one, guys. I have 40 dryers, and each one of them is 5.5 K. I have 40 dryers, each one of them is 5.5. Let's do the rating for dryers. Example, had nothing to do with the load calc. So if you guys look at the 40 will put me in the same location that I was in. So I'm going to start writing the following. The demand factor, 35. I hate to write it, but I'm going to write the percentage here, minus Okay, 35 minus, in this case, 0.5 percentage multiplied by the number of the dryers. How many number of dryers do we have? 40 minus the number, that magic number that they have for us, which is 23. 23. Any question about writing it this way? The question was, would we cash the percentage? Please leave the percentage alone. Do the math as if the percentage sign does not exist. Okay? Do not cash the percentage up to this point. So, if you go here, it becomes 35. Leave the percentage alone, please. 0.5, leave the percentage alone, times 40 minus 23, 17? 17. 17. Okay, please leave the percentage alone. It's like, think of the percentage as K. Okay? Then, so I'm going to highlight the percentage, so in a different color. So I said, please leave alone. Please leave alone. Don't cash, don't cash, don't cash, don't cash it yet. Okay, then at the end, 35 times 0.5 times 17, what's that? What's half of 17? 8.5. So that will give me 8.5, again, percentage. And this one, don't forget, minus, and this is percentage. So I'm just going all the way. And if you guys do the math for these, what's 35 minus 8.5? How much? 26.5 percentage. Now this is where, again, do not cash, do not cash. That's where we're going to cash. At the end, then I want to find the total. How many of them? I have 40 dryers. Multiplied, how many of them? Each one of them is 5.5 times. Now, this is where we're going to cash the percentage. 26.5. And instead of writing 26.5%, which you can, and do it in the calculator, I'm just going to change it to percentage. So 26.5% as point, right? This becomes 0.265, right? You move the decimal 2 slots or 2 spots to the left. And what's that with all depot? 58.2 K. 0.3 kVA. Any question, guys, about the dryers? Now, Ashley was saying you can multiply this by 35 from the get-go. Be my guest. I think so 40 times 35 times 40 times 5.5 times 35, and then you do this one, multiply, and you subtract, and that's fine. When we do it, I teach this one, guys, for the example for the state. That's how we do it. You always find the derating factor, then way at the end you apply the derating factor for the total. I think it's the easiest way. If you have a different way of doing it, by any means do it. You know. Any question, guys?
So Chad, just to double clarify, we are derating it by 50%.
Yes.
Okay.
We're derating.
My decimals and percentages are.
Yes. Yes. Yeah. If you just, you know what, Nick? If you just ignore the percentage sign and do the math, ignore it, and we at the end cash the percentage sign or change it into decimal, then you wouldn't get confused. But I see your point is, because if you come over here and make this one a decimal, it becomes 0.005, and that will completely screw up your system unless you change this one into also 0.35, right? If you change the 35% into 0.35 and start working in decimals from the get-go, you'll end up with the same answer. But I think it's easier to work with the percentage all the way until the end. Then you convert to decimals. Then you don't have to say 0.003, especially if you're sitting for a German exam master. You know, this time is very important for you. Any question, guys, about this? So that's extra, has nothing to do with us. Any question? Can I move to electric dryers to electric furnace, heat and cool? May I move to heat and cool, my friends? Okay, so that will be step number 8, number 9. Number 9, heat/cool. Now, Chris, can you please give me we have, for this step, you guys need the following, 220.51. For the air conditioning, we need 440 article, and also we need non-coincidental load, which is, these all the article apply to it, 220.60. So 220.51, it tells you the heat 100%. 440 will tell you how to calculate the volt amp for an AC system, and 226, it tells you non-coincidental loads, the loads that highly unlikely that they will be running at the same time. You can take the largest of the two. Okay? So the first one for the heat, the second one for the cool, the third one is if they are non-coincidental loads, means it's highly unlikely they will run at the same time simultaneously. You pick the largest of the two. Okay, so let's do the heat. Let's do the heat. Nick, what was Chris, what was the heat I gave you? 10K, was it 10K? 10K, multiply this by 30, that will get you, it says 10, Chad, not 16. My grandma would have done a better job than that. Okay, 10K, that will get you 300 kVA. W, when it comes to the heat, guys, W and kVA is the same because the power factor is 1. Okay, so that's for the heat. Did we forget anything? And you take it 100%. You don't increase it, you don't decrease it. 100%. Let's go do the cooling. AC. AC. For the AC, I have 10 unit. I have, what's the amp, Chris, for the units? Was it 30?
30.
Okay, I have 30 amps multiplied, what's the voltage? 240. Okay, multiply everything by 30. Okay, so the first, I don't want you guys to get confused. The first 30 times 240 is the amp. I'm going to put amp here so nobody can get confused. This is amp, this is voltage. So we convert, how do you convert how do you convert amps and voltage into volt amp? Multiply it by each other, power law. So I took the volt amp of each air conditioning. They're not giving it to me. I have to calculate it based on the amps multiplied by the voltage, multiplied by how many units. The second 30 is the number of units. Tao, my friend, are you confused between the first 30, the amps, and the second 30, the number of units? I should have picked up a different number. Everybody knows why the first 30 and the second 30. Okay, what's the answer?
216,000.
The answer is 216 kVA. Okay, so can you guys choose now, based on the non-coincidental loads, which one would you use for this step? Choose the largest. Choose largest of heat and cool. Okay, so the largest of the heat or the cool is what? 300 kVA. Anybody has any problem with this? So this is the one I'm going to be carrying all the way downstream and go cash at the bank. Any question about this? You take the largest. Most of the time, guys, your AC is the largest. Here, our example was Wacko, so we end up with the heat is the largest. But it really doesn't matter. You pick up the largest. Now, William...
Electric heat doesn't have, my experience is that electric heat costs more.
Costs more, but absolutely. Yeah, but a lot of people use gas. That's why. But AC, you don't. Now, last time I said the only way you can get AC is from a compressor. You corrected me. Almost the only way you can get cool is electrical. Well, I'm sure there's other ways, but commercially available way of getting heat is only electrical. Commercially available, but cooling. Heating, you can get it from gas or other sources of power. Any question, guys, about this step, heat or cool? You pick the largest of the two. So the 300 kVA is the one we're going to be carrying. Okay, now I'm gonna skip step number 10. I care less about in your sheet. I'm gonna skip step number 10 because it's irrelevant to what we're doing. So I'm gonna jump all the way to step number 11. If you guys read step number 10, it says add them all up. I care less about adding them at this point. Okay, I'm gonna skip step number 10 because it says add them all up. I don't wanna add them yet. It doesn't add to the value of the process. So I'm gonna go all the way to step number 11. When you guys give me the hand, move it, Mr. Curry or Chad. Please start this thing. So this is the number they're going to carry down with these steps. We're going to go to fasten in place. We're almost there, guys. Almost done. We have fasten in place and we have motors, and then we're done. Fasten in place on motors. Okay, so I'm going to go based on the sheet that I gave you guys. I'm going to go all the way to step number 11. Tell my friend, we know that why skip number 10, because number 10 is just adding him up. It doesn't add a value to what we're doing on the board. As a matter of fact, if you guys are doing your load calculation, I would step number 10. If you have my opinion, probably I would honestly just get rid of it, step number 10. But, okay, step number 11. 11, we're looking after loops. Step number 11, it says fasten in place. This is not even close to fasten in place. Not even in Hebrew. Fasten in place appliances. Appliances. Fasten in place appliances. Okay. This baby, you're going to go to 220.52. 220.53. I changed my mind. 53. Fasten in place appliances. Appliances excluding heat and cool system. Okay, so do me a favor, my friend. Hold on, Nick. Can you give me the? Do you have that sheet of the fasten in place? The first thing that we did, I think it was it. Was it
Let's see.
dishwasher? Or,
Okay, dishwasher, we got
oh, 1 second. Dishwasher. Go ahead.
1.2 kVA.
1.2 K times, how many of them do I have? 30. Okay, next. Garbage disposal.
Okay, yep, that,
Garbage disposal, what do I have?
1.5.
1.5 K times 30. Water heater, do I have a water heater?
Yep.
Water heater, how much?
5.
5K multiplied by 30. Do I have anything else?
The pool pump, no.
No, pool pump, no. I think that's, did I give you anything else?
We don't have a disposal, right?
I have garbage disposal, dishwasher, water heater.
What about microwave?
Well, I don't have
We're
it.
gonna plug that in.
They're going to be plugged in most likely. If they give it to you on the load, you add it. But we're not at it, right? These are the most common ones that you guys going to have.
Let's get the pool pump going.
Pool pump is not an appliance. Not typically an appliance. Not everybody has, almost, now we can argue, you can buy a dishwasher and garbage disposal in almost every house, but not everybody have a pool pump right in every house. Well, maybe in California and rich areas, or in your area, Chris, I don't know about you, but not in my neighborhood. Okay, but you can argue, yeah, it's not an appliance though. Okay, so add them up.
Where
So-
do you find out what is and what isn't important?
It's really vague area. The definition of, if you look at the definition, Article 100 define an appliances that's commercially available for sale, and it talks about what describes exactly what you and I think of a dryer. So, why is the washing machine is not here? I gave you guys the washing machine in my project. They said I want it included, but most of the people probably don't put it there because for the washing machine there's a laundry circuit. Remember that laundry circuit? Could be there. Okay, that's it. So I'm gonna do. Nick, do you mind if I add them all up and do the math at the end? That's easy. Okay. What's the math on that one, Nick? Anybody can second neck? Or first neck?
I come up with 222.
Okay, 222 kVA. Okay? Nick, anybody can agree, disagree? Second, third?
Came with 231. But
I agree.
231? 231?
Oh, I got it.
231, okay.
Disposal,
231. Anybody disagree? Second, two? Okay, 231. It was okay, no big deal. Okay, so that's for the fasten in place appliances, 220.53. In the sheet that I gave you guys, I said apply the demand factor in step number 12. I don't want to do step number 12. I want to do it right here. So this is the first calculation you're going to do. The second here, demand. Demand, and I'm going to just between brackets say step number, oops, I'm going to do it here. Demand, Chad, how am I going to do that? Demand. My confused between the colors. Oh, there you go. Perfect. Demand. Demand, this is coming from step number 12. I'm not going to put it as a step, guys, but I'm going to remind you it's step number 12. It says if you have more than 4, because remember if it's 4 or more, you apply a 75%, right? Step number 12. 4 or more, you apply 75%. So do I have 4 or more? You have more than 4. Look at 30 of each you have. So you have 90. So you take the 2, oops, then let's continue with the same coloring scheme. I have 231, multiply this by 0.75. And what would that give me, gentlemen and lady? Why 75? Because it says if you have 4 or more of them, cut them by, excuse me, 75. $173.3. 173.3 kVA. And that's what you're going to take to town with you. That's the number that you're going to take to town with you. This is the number that you're going to take to town with you. Meaning you're going to add it all the way as you size your service. As you size your service. One last step, the pump, and then we add them up and we size the service. One last step. I wrote here step number 12, the demand. I have the demand as a separate step, guys. If you are designing your own, honestly, I would not put it as a separate step. I put it right part of the fasten in place because it's functionally associated with it. Okay. When you guys are done, we're going to do step number 14. I'm going to skip step number 13 because it's adding them up. I care less. I'm going to add way at the end. I'm going to jump all the way to step number 14, which is motors. Yes, no, move. Good. If I ask all of you boys, will be mad at me, so I have to ask Jackson, my friend. Good. Dustin. Good. Okay. I can wait. Good. This will be on a test, guys. So because there's a lot of jumping around and all the stuff, it doesn't hurt myself to put the steps in any way that you understand it and apply it when I give you an example on the test or a final. Otherwise, it will be really, imagine a question like this with a couple of motor questions yet, all in the test, it can throw you out the window. So it doesn't hurt my feeling to use an Excel sheet if you calculated it for your final test, or you can use a cheat sheet with all the where to find the information. Okay, I'm gonna move to the last step, guys, which is step number 14. I skipped 13 because 13 does not add anything to the value here because just adding math. Step number 14, 14 motors. For motors, my friend, you're gonna go to 430. You're gonna go to this, actually 220.50, and we're gonna go also to Article 430. If you guys go there, which we did a whole motor sizing for feeders and all the stuff. If you go there, it will tell you you're going to take the largest motor in the system, multiply it by 125 plus the full load of all of the others. Okay, so Chris, what was the size of the pump that I gave you guys? I have only one motor pump.
7.5 horsepower.
Pump. So you take this pump to, it's a single phase, 240 volt, and you're going to take it to table 430.248. I think it's 248. And it's the pump is how many horsepower? Let's find that, baby. Pump, it's 7.5 horsepower. 7.5 horsepower. 7.5 horsepower. 5 horsepower. What's the full load current of that 7.5 horsepower from the table? Did we have the right table? 430.
Yeah, yeah.
Okay, good. We got that one. 430.248. Yep. 7.5 40. 40. Okay. So the full load amp is 40 amps. Who cares? Because that's how we calculate. That's how we calculate the volt amp of the pump. Only one pump for the swimming pool that they have there. They don't have 30 of them. Only one pump here, just for the whole apartment. So what do? You take 1.25. Why 1.25? Because the code says when you take a motor, guys, you take the largest 25%, the largest, fattest, fluffiest motor multiplied by 1.25 plus all the other motors. Okay, times 40 times what's the voltage? 240 plus. Do I have anything else to plus it with? Plus big fat 0. I don't have any other motors to plus it with. I got, when I put this one on YouTube, I got an email, a guy, he said, Chad, why did you multiply the volt amp by 1.25? If you guys, in reality, this is what's multiplied by 1.25, the amps. But if you multiply the amps by 1.25 and you find the volt amp, you are getting, multiplying the volt amp, the reality by it. So 240. The reason why I multiply the volt amp, because I'm adding volt amp. I'm not adding amps. You can't add amps when you size the service because amps are different. At 20 amps at 120 is completely different than 20 amps at 240. It's completely different than 20 amps at 243 phase. But volt amp is volt amp. Apple is Apple. If I tell you a 5 horsepower, guys, take this. If I tell you a 5 horsepower single phase, 3 phase, or 2 phase, it's the same amount, 5 horsepower, same amount of power. The same thing if I tell you a heater, 50 kVA heater. How much a 50 kVA heater can consume if it's connected 3 phase, single phase, or 2 phase? It's the same, 50 kVA. kVA is the same, yes sir.
You get the 40 amps. Okay.
Yeah, 40 amps was from table 248, 430.248, right? Under 40, 20, 230 in this case, because that's the closest. Okay, so when you add all this, what do you get, Chris? In kVA.
The multiplication, you end up with 12,000.
Okay, 12 kVA. I need a second.
Yes.
Okay, 12 kVA. Thank you. Now, Nick, my friend, I take it that I have not divided by 1,000 here, but you know that the answer here will be in 12,000, and I just convert it to K. Guys, when I do moving on with me, I told you from the beginning, moving from kVA to VA, I assume I don't even throw the 1,000. Second nature to you, moving from kVA to VA. So the answer here is actually in VA, but because I'm doing everything kVA, I just immediately convert it to by dividing it by 1,000. Everybody's okay with that? We're done. We're gonna go add all these steps now. So I need a friend to add all these steps first. Give me the step and give me the answer. Add him up. So we're gonna go to. We don't have pool. We're gonna go to grand total. I'm gonna go to step number 15, which is grand total. Any question, guys, before I go to step number 15, which is adding them all up? No, Nick, are you going to give me the old from the beginning, every step and how much kVA for each one of it?
Sure.
Do you mind? Because you have them written. Start with step.
I think
Chris can second you. Okay, it's 15. 15. I'm going to call, this is step 15, guys, is total demand load. Now the total demand load, my friend Nick is going to give me every step and what's the demand for. Yes, sir. Let's go back. I'm sorry. My sincere apology, but good.
For like when we're calculating the air conditioner and the heater, we pick the highest one.
Yep.
Right? And then I noticed on the previous one we did, we include the furnace on our motor load.
Yep.
How come we didn't include this?
We didn't include the furnace in the motor lab. Because it's not given. In this example, it's not given as a motor load, and we just lump summed it in the heating.
Oh, okay.
It's part of my heating system. Most of the time, guys, the furnace in particular would be part of the heating system, not as standalone. We already included it though. It's included in the heating system. Yeah.
Okay.
Whatever that. But if they give it to you, yeah, you're throwing another motor here within. If it's given, and you throw it right in here, another motor, we'll put 0. Okay, can I go to step number 1? So, okay, we started Nick with, what's the first one that we highlighted? We did I think we started at step number 5, believe me. Network, I think, no, step number 6. Can you give me step number 6 too?
70.2.
Oh, is that what we get for step number 6? Okay. Okay, now, step number 6, that was, step number 6, that was, what was the load for? 70.2K. Okay, let's go for the other one.
Then I think we wanted step number 7 for the range.
Step number 7 for the range.
Yeah.
Let's just maybe put an indicator since we are smart now. Let's say step number, was that 6? Step number 6.
Are we adding step 5?
We're adding 5? No, 5, we demanded 5. Remember we demanded it 5? 5 total, general lighting, blah, blah, blah. Then applied 6, we applied the demand factor. Okay, so step number 6, demand. All of them are demand. I'm going to just say a light. This step was for light plus small, and you guys will get the rest of it. Light and small appliances and all this good stuff with the demand. So again, one more time, was 70.2. Okay. Okay, step number 2 was range, right? Range. And this one was
56.2.
56.2. 0.3. Okay. Okay. Approximation. Okay. Step. Then we went from the range. We went into the dryer. Step number 8. Dryer. 61.4. Okay. Furnace. We didn't do 9. Electric furnace. We didn't do 10. We did 9.
We did 9.
Nine.
300.
Step number 9, that was heat, cool. Heat, cool step, what was that?
300.
Thank you, 300K. All right, so let's go to step number 10. We didn't do 10, right? We did 11. Step number 11, that was fasten. I'm just going to use the word fasten here so to remind me. What was that? 173.3K. Any seconds?
Yeah.
Okay. Then we skipped 13 and 12, and we moved all the way to 14. Step number 14. That was motors. Motor, and we found how much that one? 12K. 12K. Anything else? That's it. So that's the total demand load. What do I need to do? Add them up. I need to add all these up. All these steps. Does that make sense, guys? That's what you're going to do for me. I need 2 people to come up with the exact same answer, so we can move on with that. Phil? 673.2 kVA. Second?
Yes.
Wow, very good. Okay, so this is the number, the beautiful number that I'm going to be using to size my equipment. That's my demand. They call it demand kVA, not connected demand. Everything that you before that, every step has a connected load and a demand load. The connected load, guys, is everything that you add, just volt add, keep adding it. The demand one is when you apply that slicing, you start slicing it, cutting it down. Okay, so I'm going to go size the, this is 15. I'm going to go all the way to number 16, which is service, sizing the service. Any question about adding all these? Any question about adding these? I'm going to give you a few seconds to write things. And then I'm going to go size the service. Size the service. Questions? Dustin? No? Can I move? Who's looking at me? Oladipo? I'll buy you a lunch, man, one day. Okay, can I move, guys? William? Dustin, my friend. Chris, cool? Okay, let's go. I want you guys to remind me of 673.2 because I'm going to forget it by the time I click here. So step number, I'm going to go all the way to step number 16. 16. Oops, I'm going to use the same convention, which is this one here. 16. Okay, 16. It says service entrance equipment. I'm going to do the equipment. And also disconnect and also conductor. Conductors. I'm going to size the equipment, the disconnect, and the conductor. I'll show you how to do that. In our example, it says service entrance ungrounded conductor. That's basically the conductors. Okay. Chris, my friend, what was it? 600? 73.2 kVA equal. I need to find I, the current. Now, actually, this is the only time when we cache the kVA into I. When we start sizing equipment, I need to know the I, the amp. Up to this point, I care less about the amps. Right at the end, I need to know the amps because I need to size conductors and I need to size equipment. So divide this, what's the voltage system that we're using? 240 for all practical reasons, with some modification, this you right at the bottom here, you can divide by 208 times 1.73, and that will be three-phase system, with some modification for the ranges. So I have 240 volt, right? This is my volt, and don't forget to catch the K. What's the amp? Two people to agree in 1 amp. Now round up to a whole number here.
Approximately 2.8 K.
And we don't want K. When we move into the amps, now we're going to get rid of the K. I know that's 2,805
Yes.
and 05 amps. Anybody came up with something similar, close? Okay. 2,805 amp. 2,805 amp. Now, the moment of truth. I need to size my equipment, overcome protection device, and conductors. How are you going to do that? If you were 800 amps or less, you take this amp and you size your conductor immediately. If your equipment was 800 amps or less, is my equipment this number more than 800 amps? If it's more than 800 amps, then you're going to start sizing based on the overcurrent protection device. Because of this, the 800 amp, more than 800 amp, you match the overcurrent protection device. Less than 800 amp, you can use the conductor to size. Now, I'm more than 800 amp, apparently, right? So I need to go first, size the overcurrent protection device. So let's go size that one. Overcurrent protection device. Here's how we size that baby. Take the 2805, take this one to 240.6. Phil, what's the overcome protection device after that one? 3,000, right? If you guys go to this one, that will give me a 3,000 amp. So, what's the size of my overcurrent protection device for this system? 3,000 amp. Okay, so that's my overcurrent protection device. We found the disconnect, this baby, that my disconnect or my overcurrent protection device. I found that size. Okay, let's go size the equipment. The second thing you need to do is equipment. Equipment panel. So the panel, I want to say here, match overcurrent protection device. So what the equipment size has to be? When you go from Home Depot to order a switch gear, what are you going to tell them? I need a 3,000 amp switch gear. That's the equipment panel. So you're going to go to a panel of match, like I said, match overcurrent protection device. So what's my size? 3,000 amp. You're going to find it, everything is easy from here. The last one is, let's do the last one in a different step. Service entrance conductors. And I'm going to say here, match overcurrent protection device. See how easy that is when you go higher than 800 amp? You just start matching them. So what's my panel size? 3,000. What's my overcurrent protection device size? 3,000. What's my conductor size? 3,000. But conductors, I have to go find actual wire size. Match overcurrent protection device. I'm going to do it in the next step. Any question guys about this? So first we size the overcurrent protection device. From the overcurrent protection device, we decided the panel size, that I need a panel of 3,000 amp based on the overcurrent protection device. And then I need a conductor that can carry, or set of conductors that can carry a 3,000 amp. Set of conductors that can carry 3,000 amps. We're going to go in the next step, guys, and size that. So we did the equipment, right? Here's my equipment. The last thing I want to do is the conductors, the service entrance conductors. Service entrance conductors. Now grab your beautiful calculator and size yourself. We're going to size ourselves a table in a conductor in a second in parallel. When you guys are ready. While we're waiting for you, you can grab your calculator here. We'll do it in a second on the board. Any question, guys, about this? Any question? Can I move? May I? Yes? No? Good? Okay. All right, I'm just going to have more explanation about the sizing. So I take the 3,000 because I want to match it. I'm going to say here just to conductor size. Conductor size equal 3,000 M. You go to Viking Gray Bar and tell them I need a conductor 3,000 M. They think you came from the moon because that's not how we order conductors. We order them in AWG or KCM. So I need to convert the 3,000 amps conductor into an actual size conductor. So here's my 3,000 amp. Take the 3,000. I don't know about you guys, there is no conductor 310.16 that can carry this. So what do I need to do? I need to parallel. So the best thing to parallel for this one is, how about 10 runs? I have 10 runs. Why 10 runs? 10 runs will give me 300 amps. Okay? You can, for all practical reasons, you can pick as many runs as you want. The least, what's the rule? The least amount of runs, the better. But also hover around 500 kcm. You don't want to parallel more than 500 kcm. 600, if you stretch it, you go higher than that, the electrician will start giving you the finger, as well as cursing you and your grandma and everybody else. Because terminating these babies are nasty. You go higher than 500 kcm. For practical application in conduits, more than 500 kcm becomes really hard to work with. Okay, so divide this by 10. What do you get? 10 sets. What do you get? 300 amp. Take this one to 310.16 under 75-degree column. And you guys know why 75-degree column. What's the size?
Over 100 amps.
Yep, thank you. What's the size?
350.
350. So I have, from here, I have two conductors, 350 kcm. Two conductors, 350 kcm. Why two conductors? Two hots. What happened to the neutral? I can derate the neutral. I can derate my neutral. What happened to the neutral? I can derate my neutral. So two hots, 350 kcm, and also do not forget that's going to have 10 sets. So this goes directly with it. 10 sets of two conductors, 350 kcm. 10 sets. Now we're going to open the can of worm for the neutral. Any question about this before we go find the neutral? Now, here's what you can do. You can pull a full neutral and call it a day. So this would be how many conductors here? 3 conductors. Let's go to the bar and drink. Have fun. Right? That's good. Or you can, most likely at this size, guys, you need to derate. Why derate? Save you money. Why derate? It saves you money. So we're going to go back and we're going to size our conductor right on the steps, guys. You're going to see it's going to be very easy now because we have everything calculated. Show you how easy that would be. Because everything is calculated.
These things are going in metallic.
Okay, thank you. Now how would this go? Let me draw that one for you. So suppose that these, how many ones do we have? I have 10 of them. 1, 2, 3, 4, 5, 6, 7, 8, 9. We don't have room in the board. 10, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Think conduits like this. A lot of power. Each one of these conduits, that's how physically it's going to go. Each one of these conduits, I'm going to pull. Let's take this one and you guys can translate it. Each one of these conduits, it's going to go a hot. That's phase hot 1. And the second hot. Give you the gravity of this system. So that's what it's going to look like. Each one of them is going to have 2 conductors as of now. 2 conductors. We're going to get the neutral in a second. Each one of these conductors, 10 conduits. What type of conduits? If you're for this system, most likely you're coming from underground PVC. Can I use EMT? Bring it on. Can I use rigid? Yes. Most likely a system like this, guys, will be coming from underground. So you're going to use PVC schedule 40 or 80. 80 is preferred for utilities for protection. So most likely this will be a real life schedule 80 PVC underground ducts.
Is that the thickness in millimeters, like 40 or 80, or what is the numbers?
The thickness is bigger and the interior diameter of both of them is the same. No, the exterior diameter is the same, but the interior diameter is smaller for the 40, for the 80, because the 80 can get you less conductors in it. What they do, because then you can use the fittings of 40 or 80, because the exterior diameter is the same. You can use the same fittings, but inside it, they make it thicker. They make the 80 thicker. Okay, can we go quick and size the neutral, guys? You have energy. Doesn't take much. It doesn't take that long. I'm going to use the neutral. I'm going to go back to your steps, and I'm going to use green for the color neutral. Green on my screen here. I'm going to go back step by step, and you're going to find it's very easy. It's already calculated. Very easy. Step by step, we're going to go size and neutral. Okay? And then I'll give you a couple of rule of thumbs. Any question about the phases? Ungrounded conductor size. Done. Now, you guys were going to go size me a conduit now, based on what type of, we'll talk about what type of insulation. We haven't talked about the insulation. THHW, most likely underground. But we'll talk about the conduits in a second. Okay, what I'm going to be doing, Oladipo, my friend, I'm going to go back to step number 1 and start pulling things to size and neutral, putting it on the side. So if you guys want to follow with me, go back to step number 1 with me, all the way. It's a nice thing about having a smart board. Okay, let's go here. You guys remember that one? I'm going to highlight now everything you're going to see in green in my color is going to be neutral. Color green is going to be neutral for me. So if you guys color coded, anybody's color blind here that can admit? Okay, a couple of things that I'm going to drop from the calculation. Look at this one. Do you think this pump is going to apply for me? It's 240. Do you think it's going to contribute to the neutral? So this is dropped from my calculation as a neutral. Okay, let's go. How about the water heater? 5K. 5K, 99% of the time is going to be 240. If you don't know, I'm going to tell you it's 240. So I'm going to put here 240 volts. So what are you going to do with this? Drop this water heater. I care less about the water heater. Okay? Dishwasher, 120. That's count. Garbage disposal. How about dryer and range? You guys remember the dryer and the range? The dryer and the range. And also this is, I'm going to make this one 240. So the air conditioning, look at the 240. What's going to happen to the air conditioning? Cross the air conditioning, not working. How about the heat? The heat, I'm running all my heaters at 240. I just wrote it down. If you don't know, most likely it's going to be 240. I'm telling you it's 240. What do you do? What happened to the heat? Cross it, done. Right?
Do we take the demand or the connected number?
With the demand. We're going to be doing the demand. But I'm just isolating the things that doesn't count for the neutral. All the cooling, the heating, range. Remember the range we do what? 75% based on the code. We do 75% of these. So these I'm going to just put a dot next to them. Garbage disposal counts, voltage, everything else counts. So I dropped the water heater from the get-go and the AC and heat. Okay, we haven't started yet. So just to give you an idea. Any question here, everything else will count. And the pump is dropped. The range and the dryer will count as 70%. I'm going to tell you how we're going to go with them with the steps. So that just give you an idea where we're heading. Okay, let's go to step number 1. Step number 1, everything stays the same. All this for the load calculation stays the same. All the way, guys, to the demand. So where's my demand? So everything for up to step number 6, I'm going to go use, how am I going to use this one? Here. I'm going to say neutral and I'm going to put it right here. And I'm going to carry this one, 70.2K. Can you guys do that? This is for here. For step number 6, I'm going to carry as is the 70.2 for this step, as is, nothing. Why? Because these are receptacle and light. And what do you think the receptacle and lights are going to be? They're going to be connected 120. So up to 6, you're going to carry, for step number 6, you're going to carry as is. Can you guys highlight this one so you can give it to me at the end when we add them up? Any question about this? As is. We didn't do anything here. You'll have to apply to the manufacturer and everything else, and you came up with this number, carry it as is for the neutral. Okay, so write to yourself this number as is. Go to next. Okay, this one we didn't do much here and yet. Let's go all the way to the range. For the range, here's what you guys are going to do for the range. I'm going to do it in green. So I'm going to say neutral, and I'm going to take 70%, 0.7 times this number, 56.3 K, and I need my friend to give me the 70%, and I'll tell you where this comes from. This is coming for the range from 220.60 61B, right? 220.61 B for the neutral, 70%. Permitted procedure. Unlike that I gave you guys in my sheet 75, that should be 70. So my sheet is wrong. The sheet that I told you 75 with this step, it's actually 70. So B, yep, that's well feeders over this one, 70%. Okay, Nick, what's the 70% of this number?
39.4.
How much?
39.4.
39.4. Okay, K. Why do you, so I'm going to put the same thing, N load. Here it's going to be 39.4 K. And I'm going to ask you guys to give me this number later on. Okay? Where did this came to be? Why did I do what I did here? For the range, it's going to be 220.61B. And again, this is for Mr. Neutral. The article that tells you 220.61B, the neutral, how to calculate the neutral, right from there. Take 70% of this number, 39.4K. Questions? Cool?
So far, we've added the result from step 6.
Yep.
You're adding them up, right?
Yep, we're going to add them up at the end.
Creating the unbalanced. flow.
Yes, absolutely.
So far, you've taken step 6
And step 7.
and step 7.
Yep. Any question guys about step 7? Step 7. I'm going to go to step,
That runs at 240. Is that considered balanced, or are they?
because they have things running at 120. The range, guys, you will have some control and some things running at 120 in the range. So the smarter than Chad decided, hey, your demand load for the range, for the 240, for the on-ground conductor, will not count all of it, but just account for 70% of it. This is from 220.61B.
So they're saying that 70% is unbalanced?
Yes. It could be as high as 70%. So you do the same calculation. Rob, do you guys see that you did the same calculation? At the end, you took the demand and you cut it again by 0.7, 70% for the neutral. Everything, all the calculations stays the same though. As you guys build your sheet, that's what you should be thinking, is it stays the same. Okay, can I go to 8? May I go to 8? No.
Hey Chad, I think we should make little signs that says stop, go.
Shall we? Is the sign go now or stop? Who's going to be in charge
We
here?
have little
Just
flags.
go.
William, good?
Good.
Ashley, we're good? Zach, okay. Let's go to step number 8. Because I get confused when I look at you guys. I don't know if I should go or not. Okay, dryers are the same thing. For dryers, you're going to go to 220.61B. Again, for the neutral. It will tell you the same thing. Take that for neutral calculation. Here's what you're going to do. You're going to take 70% or 0.7, which is 70%, 0.7 times this number, 61.4 equal. Who's going to give me the answer? Same calculation, just take the 70% of it. Phil?
43.
43 even? 43. kVA. Okay, so I'm gonna put my neutral here and take my neutral as 43 kVA and highlight it. And I said, could you please carry this one later on downstream for me? Okay, here's my neutral. 70% of that baby. Number 8, 70%. Now next you're gonna be giving me these. Huh? Step number 8. We skipped, we're going to go to step number 9. What did we say about step number 9, guys? Heat and cool. What did we do with the heat and cool? Out the window. They are 240, careless about them, nothing on them, that's 120. So when I'm done with the dryer, are you guys done with the dryer? Done? Cool. So if you go there for my dryers, now for this step, oh, this is extra. For this step, the heat and cool, I want to say just to make sure that I counted for neutral equal big fat 0. Okay? So my neutral here is big fat 0. Nothing is carried. Cool? 0 here. Nothing. Because everything is 240. So skip this basically. All right. Fasten in place. That's where we're going to wake up if you're sleeping. For fasten in place, I'm going to do it here, guys. 1.2K times 30. This one's going to continue 1.5K times 30. And that's about it. How about this? This one would not count. Why wouldn't the 5K count? Because we said the water here was what? Was 240. So I need somebody to give me the answer for these. So 1.25, 1.25, where 1.2 times 30 plus 1.5 times 30 equal 81. Anybody came up with 81 when you add these, all these together? Second, 81. Well, no. 1.2 times 30 plus 1.5 times 30 equal 81.
What about the demand pressure?
We're not done yet. This is just here, this step. We're coming. A good point. Here's my here. Then I'm going to take this one, 81, and multiply it by what's the demand factor? 0.75. So take this times 0.75 equal, 0.75 times 81 equal 61. 61 kVA. Okay, so my neutral load is going to be 61 kVA, and that's a step that I'm going to be carrying all the way downstream. Did I do it wrong? 61. I put the 1 here. 61 kVA, right? And if the math is okay, 61. That's it. So the only difference is I got rid of the 240, guys. I threw the 240 out the window. Okay, so that's fasten in place. Step number 11. What do you think step number 14 for motor is? Yes, sir. Yes, ma'am. Because if it's more than 3, you multiply by 70. 4 or more, you multiply by 70%. I know you're looking at 1, 2, Chad, but each one of them is what? 30. So I have 60 equipments here. Yeah, I know. You look at, you said you did 2 calculation, Chad. You look like it's 2 equipments, right? But remember, there's 30 in each, 1 in each unit. So in reality, how many equipments do I have here? 60 equipments. So I apply the demand factor because it's 40 or more, right? I mean 4 or more, you apply the demand factor. Make sense, actually? 4 or more. Okay. Did you guys get that one? Let's go to step number 14. So neutral here. Neutral equal big fat 0 for this step, right? Why? It's 240. Here less. If there was a 120 motors, what do? Add them up. Okay, we're done. Let's go to these steps now. Now I want my friend Nick for the neutral to give me all the sizes. I know this one should be 70.2K. Right, Nick?
Yeah.
If this one should be 70. I hate erasing things. 70.2K. Okay, let's go to step number 7. What was for step number 7? Nick, we derated
The
it.
range, and we've got 39.4 kV.
39.4K. Step number 8.
The dryer, 43.
43K. For the heat cool, 0K. For the fasten in place,
60.75.
60. I thought 61 I did. In my, I said 61. That's okay.
Maybe that's what I got.
61. Okay. I just want to continue with that. And what do you get for the motors? 0K. Add them up for me, will you?
I got 213.35.
213.35. 213.35 kVA. Anybody disagree with my friend? Well, instead of 35, let's make it 0.4, yeah. Anybody disagree? Anybody disagree? 213.4 kVA. 213.4 kVA. Any question about that one, guys?
1.6.
Huh? Is it wrong?
Make it 214.
214?
1.6. No.
214, you got it, buddy. Oh, well, we're not going to fight over 0.6, are we? 214.
You're breaking my balls off.
214 kVA.
2.46.
Okay. Is that 214?
Yeah.
Okay. All right. We don't, yeah. Plus or minus 1K is not going to make a difference. 214K, 214K. Cool. Can I guys jump to the next step? And now we're going to size and neutral. Cool. Okay, let's go size and neutral. Okay, now I want you to guys give me the number. Now I'm going to do the neutral right for this step right here. For this step, give me all the people 214, right? I will do 214 divided by 240. Now, this is where it drives the people nuts. It's a neutral, Chad. Why are we dividing by 240? Remember, there are 2 legs for the neutral. What's going to happen to technically, probably half of the neutral load is going to be on leg 1, and half of the other neutral will be on leg 2. So that's what you're taking into consideration. Yes, at the end, they're neutral loads, but they should be balanced, and they force you to balance it. Even if you try to unbalance it, it will be balanced. So if you put circuit 1, 2, 3, 4, 5, 6, they're balanced. You're balancing the loads. So that's why we find by, okay, what's the, why divide by 240? What's the answer?
889.
How much? 889? 889M. Anybody disagree with my friends? This is for your and Mr. Neutral, for your neutral. Anybody disagree, guys? 889. 88. 8891. 891. How many?
I got that.
891. Okay. 891.
Yeah, I just browned until the very end.
891. We're not gonna fight over that one. 891. 891. Okay. Now, Ashley, do we land the overcome protection, the neutral and the overcome protection device? No. So I don't need to go size the overcome protection device because it's not going to be landing on an overcome protection device. Careless. Right? We don't land the neutral on a fuse or on a circuit breaker. You're not supposed to, especially on a fuse. Okay, so I have 8891. Now, from this number, do I care about the overcome protection device? Do I size overcome protection device for the neutral? No, it doesn't land on neutral. Do I size the equipment based on the neutral? No. The neutral, these two guys are always sized based on the phases. So drop these two. The last thing I want to do is just the neutral conductor. Just the neutral conductor. So 891. Okay, there you go. I'm going to take my 891. Now, here's my question for you. Do I have an option other than paralleling 10 sets right now for the neutral? Do I have an option? No option. Why? Because I made a decision to parallel the phases as 10 sets. Well, guess what? The neutral is going to happen. 10 sets. Why? Because the code says that the conductors of the same circuit must run in the same conduit, cable, or cable tray, or cable. So you need to run, you have to parallel 10 sets now. 10 sets. Cool? All right, so I have no choices here. I have no choice. I am forced to parallel 10. Why? Because I already paralleled the hot sets 10. So that will give me 89.1 amps. Take it to the same table, guys. Now I know it's 89.1 less than 100, but remember, the whole equipment is rated for more than 100. So we go to 75 again. Go to 75. The same table, everything else. What would that under 75 give you? Number 3. Number 3. Okay? No problem. There's one little problem here. Number 3. Up to this point, if we are not paralleling, no problem. If you guys, the rule of paralleling, the code says when you parallel conductors, they have to be the same, when you parallel, the same size, the same insulation, the same conduit, the same length, the same termination, and the same termination, and you cannot parallel less than number 1 aught. Did you guys see that? Because we are paralleling, I cannot parallel less than number 1 aught. Is 3 less than number 1 aught? Yeah, so what are you going to do with all your beautiful calculation that you did? Open the window, throw it out, and what's your size of your conductor? 1 aught. Why? Because the code says if you parallel, you cannot parallel for power less than 1 aught. How about for control? No problem. If you're doing a control circuit, you can parallel number 14. But for paralleling, you cannot parallel more than 1 aught. Okay, so because of paralleling, then I'm going to say here, so then this will be 1 aught, the size. I'm going to write here because of paralleling. Yeah, I know somebody's going to ask me about that one. I forgot the code. I'll get you in a second here. Anybody can go for the reference when we parallel. I just forgot the reference for that one. All conductors, when you parallel them, have to. I'll get you there. I think it's 300, if I remember. 5. Okay. Okay. I have to check it, buddy. I forgot. How much? 310 dot? You're the best. 310 dot 10 H. 15 310 dot 10 H. Thank you. Conductors in parallel, and it's number 1. The rule is number 1. So 310.10H. Thank you. The reference for this is 310.10H. That's where we parallel conductors. Thank you, Ashley. 310.10H. And if you guys read the first one, number one, it will tell you what? Conductors less than number one ought shall not be parallel. You can't parallel them. Okay, so take this. Then I'm going to go and pull another conductor, guys. Here's my neutral, my neutral, my neutral, my neutral. I'm pulling all my neutrals with these conduits. So, right, I pulled my neutral, have 3 conductors. And then to write it down, then I would say here, 10 sets of also 1 conductor size of 1 aught, AWG. So what are you going to do? You're going to have 10 sets of 2 conductors 350 kcm and 1 conductor 1 aught, and 1 conductor 1 aught, and 1 conductor 1 aught. And if that's not enough for you, there's one more rule, my friends, that's going to make you scratch your head here. Okay, can I just go? I usually go this one in the commercial, but you have to understand because we're parallel. There's one more rule about grounding conductor might give us a higher, even higher size, guys. Okay, there's this rule I want you guys to go to when you size a grounded conductor. Grounded conductor, this one from 250.24C. If you go to 250.24C. C 250.24A, B, and C. Sizing. It says, if you guys go there, it says the grounded conductor shall not be smaller than the required grounding electrode conductor. So we're doomed. It says, if you read this one, this article, it says the grounded conductor shall not be smaller than the grounding electrode conductor, or if you continue, or if it's more than 1100 kcm, less than 25% of 1100 kcm. So based on this rule, back to the grounded, the whole mess here happening is because we are paralleling. The whole mess happened because we're paralleling. Here's what based on this rule. A grounded conductor, neutral, neutral conductor, or grounded, grounded conductor. If you guys go through this, here's what it tells you. How many sets did I run? How many sets did I run, guys? I have 10. 10 sets multiplied each set by, what's the, each set size, the phase was 250 or 350? 350, the phase size? The size of the phase conductors was 350. So multiply this one by 350K. What would you get? You get 3500 kcm. Everything that I write right here, guys, is in 250.24C. Everything. So is this number 3500K more? Is it more than 1100 kcm? Is it more than 1100 kcm? 3500K. Is it more than 1100K? Yes. The answer is yes. Then what do you need to do? If yes, you're going to take 12.5%, 12.5% times 3500K. And what do you guys have 12.5% of this number?
Where are you getting that 12.5?
Read through the same article. It says if it's larger than 1100 kcm copper, then you take 12.5% of the total.
This is in that 250.24.
This is in 250.24 C1. C1. Actually, see, let's go directly to C1 here. Give you right into where we are. C1. So here we go. 12.5% is 0.125 times, give me 1 second here, buddy. 3500 equal. That will give me 438 kcm. Okay, go ahead. I'm sorry. Why are we in C1? Grounded conductors brought to the service entrance equipment. Parallel conductors in 2 or more raceways. If the ungrounded conductors are installed, blah, 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 in 2 or more raceways, the grounded conductors shall also be installed in the parallel. The size of the grounded conductors shall be based on the total circum area of the parallel ungrounded conductors in the raceway as indicated in 241 C1. So it refers you back to C1. Right? It refers you back to C1, and it will tell you, oh, by the way, don't forget that you can't go less than 1 aught. So it refers you, C2 refers you to C1. I'm sorry, guys, that's a code.
How much glue and what kind do you have to snip to come up with this kind of rating?
I know. So, do you see that how it refers you back to C1 for the sizing? Okay. It tells you percentage, blah blah blah, in 250, but not smaller than. So whatever you come up with, but not smaller than 1 aught. Okay, so with this, you guys agree with me? What's the next standard 430, 43 kcm? What's the next standard? Where would you go? So you're going to take the 438 kcm, and you're going to take this one to usually table 8, chapter number 9. What's the next standard from table 8? You can go off of 310.16. What's the next standard kcm, guys, for this? 500? Is it 450? From table 8? If you guys go right to table 8, 300. There is no, between 400 and 500, there's nothing. So what do you guys think I'm going to be using? 500. So this is a 500 kcm. 500 kcm. That's interesting. Now, if that's not confusing enough for you, there's also another rule, guys, that says the grounded conductor shall not be required to be more than the ungrounded conductors. So in a case like this, look at that. My neutral end up with 500 kcm, and my hot is, what's my hot? 350. Your neutral does not have to be larger than your hot. So we go back to square zero where we pull. It takes precedence is the neutral neutral conductor. The neutral conductor does not have to be larger than the hot conductors.
How would you know that?
Well,
Tell me how
when you do the
know that
math.
it takes precedence over this rule.
Yeah, I'll give you. I can't remember where the rule is, but I give it to you.
No, I
I see your
believe
point.
the rule is
Yeah.
there. But
How
where
do you
does
know?
it tell you the precedence of the rules?
Well, in the article, it will tell you if it's then this, if this is then that.
Yeah, but,
Yeah.
okay, so you're over here and it says it must be this way.
Yeah.
And you have another thing that says it must be
Yes.
this way. Where is the arbitration between the two? Where in the book does it say this chapter overrides anything in this chapter? Because otherwise it's a standard.
There is a link. There is a link that links you to it. Okay, so long story short, my friends, based on all this, my conductors, based on all this, your conductor is going to be 10 sets of 3 conductors, number 350 kcm THHW. After all these jumping around.
That's what I'm saying.
But because the reason for this, because we have a huge system, a 3,000 kcm. 3,000 kcm.
Would they really run 10 pipes or would they try and put
10 pipes. They will run 10 pipes. Yeah. We ran multiple pipes, 12 and 13 and 14 pipes. So, luckily, guys, we do this in the commercial. We do all this in the commercial all the time. Luckily, my friends, you're not going to end up, this is really, I should have left. I wanted to leave this caroling part into the commercial. I go over it more in details. But the example has it in the book, so I thought just to introducing it. So all this stuff, long story short, we did all these calculations, why not, and all this to end up with the same size conductor because of the way we paralleled the sets, because of the way we paralleled our sets. What was it? 310.10. Okay. Okay, I'm done with that one. I just owe you I owe you guys, where does it say that the grounded conductor does not have to be larger than non-grounded conductor? Let me find this one for you. That's it. Thanks.